of locomotives is rolling down the railways of the world. Revolutionary technology has overcome traditional barriers to produce trains unlike any before. Super diesels pull mile-long trains. High-speed locomotives cover miles in mere seconds. And trains of the future that will travel using levitation. Each super train is a product of challenge and innovation, begun decades ago, when great steam locomotives ruled the rails. High-speed trains are traveling the world. This super-speed train is the TGV. It is the world's fastest commercial train. Traveling faster than some airplanes fly, it can cover 150 miles in less time than it will take to watch this program. Many nations have super trains that clock over 100 miles per hour on regularly scheduled runs. For 2 decades, bullet trains have been streaking between Tokyo and Osaka, carrying over 1 billion passengers. Average speed, 150 miles an hour. No one is standing still when it comes to pushing the technology even further. Using the latest advancements in design, construction, and testing, transportation scientists and engineers are developing new methods to move cargo and people by rail. The push for better and more efficient railroads has created a breed of locomotives that is unlike any which preceded them. Super trains of today are technological marvels. Their advancement is shattering the very concept of rail travel. However, their story is a story that began when super trains belched smoke and sucked steam, but hauled the world into a new age. Union Pacific's fleet of locomotives was one of the most powerful, their designers always pushing the technology of the day to new limits.
Well, bigger, more powerful locomotives evolved from the same thing that bigger, more powerful diesels are evolving from nowadays. It's a never-ending story. The size and weight of the freight and passenger cars and the amount of cargo they carry has always grown. And about the time a designer comes up with what he considers to be the ultimate locomotive, some other designer comes up with a bigger, heavier freight car, or the railroad needs to run the trains faster to service customers. And that's been going on since railroads first came around.
Starting in 1936, Union Pacific built a beast of a locomotive that dwarfed all others. Stronger than 2 of today's diesels, more powerful than 100 full-size automobiles. Water circulated through more than a mile of pipes. Its massive boiler generated a red-hot cyclone of superheated steam that drove 4 cylinders, each larger than a 40-gallon drum. Its mighty engine throbbed with over 5,500 horsepower and weighed over 1 million pounds. That's more than 2 empty 747s. They called it the Challenger.
You look at these things and you have to remind yourself that these things were designed on a drawing board. They were designed with slide rules and stuff like that. There was no computer-aided design or any of that kind of stuff. There was no way to do stress tests. This was all done by rooms and rooms full of engineers, hunched over draft boards with the slide rule and pens and pencils and stuff like that. And they were built in American factories. They were built the hard way, you might say, the good old blue-collar worker, the old industrial base of the country. And when you look at it that way, it's pretty good, solid engineering. It's good American craftsmanship. And it represents an era that isn't there now. Now everything's made out of plastic, everything's designed on computers, and I'm not saying that's bad, it's just different.
The Challenger was designed for fast freight, but occasionally pulled passenger trains. It had a top speed of about 70 miles per hour. Power was supplied by 12 driving wheels, each almost 6 feet tall. It was referred to as a 4664, meaning 4 wheels in the leading pilot to help guide the locomotive into curves, 2 sets of 6 driving wheels, and finally, 4 trailing wheels, which support the rear of the engine and its massive firebox. Each set of driving wheels had its own steam cylinder. The result, in essence, is 2 engines under 1 boiler. But even its strength wasn't up to hauling freight over the Continental Divide. The curves and steep grades of the Rocky Mountains seemed an impenetrable barrier for locomotives of the era, even more than the strength of the Challenger could master. A larger locomotive was needed, so Union Pacific decided to build one. Some thought it couldn't be done because the tight curves in the track would be impossible for such an enormous beast to negotiate. Critical design problems that resulted from the size and length of this new locomotive had to be overcome. The extra length would mandate the need to advance a revolutionary design used on the Challengers. This was known as articulation.
They couldn't go up because they had reached the limits of height. They couldn't go to the sides because they'd reached a limit of width. But they could go lengthwise. And when you have a locomotive that's going to be 130 or 132 feet long, it won't go around any kind of curve at all if it's rigid. So they came up with the articulation. An articulated locomotive is one that is actually hinged in the middle, or the running gear is, not the boiler, but the running gear is. The front part of the boiler rests on a sliding plate, and there's a hinge pin in the middle of the locomotive. So the front half of the running gear can ease into a curve while the boiler stays straight.
The articulated design helped to make possible the most powerful locomotive that ever rolled down a track. A titan among giants. It was the first and last of its kind. It was named Big Boy. There were 56 of these enormous locomotives built. They generated 7,300 horsepower, weighed over 600 tons, and were half the length of a football field. It had a wheel arrangement of 4-8-8-4, giving it more power and making it 10 feet longer than the Challenger. Its strength was legendary. These locomotives could pull long trains up the steepest grades. They conquered the Rocky Mountains without breaking a sweat.
The Big Boy was the largest steam locomotive ever built. It was 135 feet long. It had 16 driving wheels. It had 4 cylinders. It had an enormous boiler and grate area. It was coal-fired. It had a tender on behind it that would carry 32 tons of coal and 25,000 gallons of water. So in the 4000, which is the Big Boy, you wound up with a lot of tractive effort, not quite as much horsepower as you might want. The Big Boy and the Challenger were kind of designed as a package. So at the top of the hill, you traded that locomotive for one that had a little less tractive effort, but a lot more horsepower. because now you're going across the prairies, now you want the speed.
So rather than compete against each other, the Challenger hauled the high-speed runs, while the big boy conquered the steep grades. In the two, steam engine technology had reached its pinnacle of size and power. But fundamentally, both behemoths operated like any other basic steam engine. Water and fuel are fed into the boiler from the tender coupled behind the locomotive. From the firebox, hot gases flow forward. The high-pressure steam expands in large cylinders. The cylinders move pistons that are connected to rods that turn the driving wheels. For the Big Boy and Challenger, this process was double, and superheated steam was created in order to power both sets of drivers. The steam locomotive was a cantankerous, fragile beast. No two were the same. Each had a personality of its own.
Steam locomotive doesn't do anything for itself. You're continually adjusting the machine to do the amount of work that you want in the most efficient manner. And you do that by what it's telling you. And it talks to you through the seat of your pants, and it talks to you through your ears, and it's telling you what it wants, and if you don't give it what it wants, it'll bite you. It's always been said that the best engine crews kind of bonded with the machine.
This kinship between man and machine, forged by the iron horse, has never been matched. Perhaps it was the sense that each were, in their own way, running against time.
A steam locomotive consumes itself. Every time you build a fire in it and steam it up, and every time it moves a little bit, it's slowly wearing itself out. And that's one of the natures of the beast. But the downfall of all steam locomotives was their fuel consumption. In terms of how much fuel they used for the power they put out, they were horribly inefficient compared to a diesel.
On a typical run, these locomotives would consume 1 ton of coal per mile, turn 25,000 gallons of water into steam, and require a stop every 20 to 30 miles to replenish its supply.
The transition from steam to diesel started rather slowly, kind of at the behest of people who saw something in the diesel that they didn't see in steam. It stayed slow until World War II, when you couldn't get diesels. But after World War II, the change became very rapid, and between the end of World War II and probably the middle 1950s, steam disappeared from commercial service.
This program is brought to you in part by Gateway. Let's talk about your Gateway.
My dad always said,
as soon as I get a computer, you'll come out with something better.
So, to make sure people like Dad always have the latest computer, we've invented YourWare, technology that grows with you. For just $49.95 a month, you get a computer with an Intel Pentium 2 processor, unlimited internet access, and you can trade it in toward a new one in 2 years.
What do you call this thing? YourWare.
Call 1-800-GATEWAY, and let's talk about YourWare.
There are times when you can't afford to miss a message. When you get Skyward Plus from SkyTel, you get the message every time, guaranteed.
The new Dodge wanted to take the sport utility concept to a higher level. Enter the new Durango. Its best-in-class power, cargo space, and seating for up to 8 raise the bar considerably, as do its strongest-in-class frame and its stable, longer, wider stance. Dodge Durango, a higher form of sport utility, from top to bottom. Durango, new ground for the new Dodge.
Hi, I'm Bob Vila, and this is Craftsman innovation at its best. Craftsman RoboGrip pliers are the world's first self-adjusting one-handed pliers. With just a simple squeeze of the spring-loaded handle, the jaws automatically adjust. The Craftsman RoboGrip works on faucets and hoses, or for auto repairs. It has hundreds of household uses. And because Craftsman RoboGrip pliers are from Sears, your satisfaction is guaranteed or your money back. Call the number on your screen right now to order your Craftsman RoboGrip.
You're watching the Discovery Channel. Explore your world.
This young man spoke from his soul. He spoke from the depth of his soul.
I like to serve.
From the people who knew him best.
Somehow he stirred in people things that hadn't been stirred even with his brother.
An intimate portrait.
It would, I think, have been a different country had Robert Kennedy identified us.
Robert F. Kennedy, a memoir. Premiering tomorrow at 8 Eastern, 7 Central on the Discovery Channel.
Some people thought I was wacky to start this business. And they were right.
Welcome to the Boston Duck Tours.
But now we're pretty big fish. In a river, actually. And I need to keep track of my business no matter where I am, which I can do now with OfficeLink from Bank Boston. With a single click, I get my exact cash position up to the minute. With another click, I can transfer money from any account. It makes it easy to keep your ducks in a row.
New OfficeLink. Computer banking made simple.
We were there to help you plan your dream vacation. And we were there to help you prepare for that special occasion. We helped your small business grow, providing you with many new customers. Local Tel Yellow Pages. When you need us, we'll be there. Local Tel, a trusted name in Yellow Pages.
By the 1950s, the diesel locomotive had become the reigning king of the rails. While the first diesel engines were small in size and horsepower, they were tremendously efficient when it came to fuel consumption and labor costs. These diesels could travel about 750 miles on 1,000 gallons of fuel, require only one operator, and be turned around after service in a very short period of time. Over the decades, diesel locomotives continued to evolve, and with the improvements came the super diesels of today. With names like Dash 9s, SD80 Max, and AC 6000s. Not as glamorous as Big Boy and Challenger, today's diesel locomotives are far more efficient than the great steam engines. Integrated with computers, satellite navigation, and digital systems, these super diesels are propelling railroads into a new era of technology. All diesel locomotives are, in a sense, no more than an electrical power plant on wheels. A diesel engine powers an electrical generator. The electricity is transmitted to electric motors on each truck, which drive the wheels. Simple. But now add a dozen other systems. And what was simple becomes massively complex.
I think the biggest design challenge in designing modern-day locomotives is not so much the technology itself, but the complexity of the product. This locomotive contains over a dozen computers, and it's not simply just a collection of individual components, but it really is a set of highly integrated subsystems.
In the wide open spaces of North America, hauling freight has become the railroad's biggest challenge. A locomotive pulling a mile-long freight train is locked in a titanic struggle against immense powers of force and resistance. It's a precarious battle against inertia and momentum, requiring delicate control of awesome levels of horsepower. Now, a new fleet of super diesels has taken to the tracks that is stronger and more powerful than ever before. The great diesel locomotives are capable of hauling massive amounts of heavy cargo in trains of 100 cars and more. Freight train handling has become a science. An immense mobile equation based on horsepower and weight. Locomotives can be thought of as building blocks, power units with varied horsepower ratings. They can operate independently or be coupled together. Connected with electrical lines, they work in tandem, controlled by one conductor in the lead locomotive. This modular design makes calculating the number of locomotives needed for a train a matter of simple arithmetic. Most older units are capable of hauling 1,500 tons of freight each, while super diesels are capable of pulling over 2,000 tons. For instance, an average train of 4,500 to 6,000 tons would require 4 older locomotives to pull it. The same load would require only 3 super diesels. This results in fewer locomotives to move the same amount of material, as well as a savings in labor and equipment costs. How about a mile-long coal train? Nothing to it for today's high-horsepower diesels. Of course, you must also figure the grade of the route, curves, and necessary speed. These factors all add resistance to the load and vastly complicate the equation. While horsepower can always be increased by adding more locomotives, the principal challenge facing today's designers is in conveying the horsepower to the rails.
The locomotive operates on steel rails with steel wheels, and the actual contact patch that it sits on is only about the size of a small coin. This locomotive here with 6 axles has 12 wheels, so you can imagine the entire locomotive sitting on something about the size of 12 coins. And so really the trick is being able to transfer the horsepower down to the rail through that contact patch. And that's accomplished by aggressively controlling wheel slip.
The critical moment for a locomotive is starting a train rolling. It's a titanic tug-of-war that pits a locomotive's power against cargo weighing up to 20 million pounds. If its wheels slip, the locomotive loses. Wheel slip burns up equipment, shorts out electrical systems, and makes pulling a train impossible. Preventing wheel slip is a technical feat that requires delicate control over awesome levels of pulling power. Onboard computers monitor power output, while another not-so-high-tech method is employed. For years, locomotives have relied on sand blown onto the rails by hoses in front of the wheels to help adhesion. A typical locomotive may carry a ton of sand and dispense it as needed to control slippage. So starting a freight train rolling is similar to getting an automobile moving when it's stuck in snow and ice. This super diesel is one of today's best. It can reach 70 miles per hour and has the power to start a 5,000-ton train. It's the SD80 Mac, about 80 feet long, almost 16 feet tall, and weighing in at about 420,000 pounds. It carries 6,000 gallons of diesel fuel and is capable of putting 5,000 horsepower down to the rails. With a maximum braking effort of 96,000 pounds, it is one of the most advanced locomotives. All of these advancements are aimed at avoiding railroad disasters of the past. Today's super diesels have close to 100,000 pounds of braking power. It is the result of new brake systems on the cars.
The worst was I'd be at a party, and someone would light up a cigarette, and that cigarette would look like filet mignon to me. My mouth would practically water. Without Nicorette gum, I could never have quit. I could chew a piece when I needed it, and I would regain control, and it would soothe my cravings fast. After a piece of Nicorette, a cigarette would only look like Top Round to me, and that I could resist.
Nicorette gum helps you fight your cravings, your habit, your way. You can do it. Nicorette can help.
Isn't this heaven?
2 whole weeks, yeah.
No kids, no fun,
No taxes.
no trading, and no Kramer. Honey? Honey?
For James Kramer, the Provocative Market Insight Series investors can't do without. It's street.com. It's pure, uncut, and free for 2 weeks.
Who is this Kramer?
Call 1-800-996-4TSC.
It's late, it's wet, and a flat tire puts you up against the wall. Wouldn't it be great if you could just drive to safety? Now you can with new Goodyear Aqua Steel Run Flat. Even with no air pressure, you can drive up to 50 miles at 55 miles per hour to safety. Aqua Steel Run Flat. Only from Goodyear.
Go get it! Go get it!
Hey, I'll race you across.
Oh my gosh, I can't believe that rope swing's still here. Fetzer. These are the days. Enjoy the wine. Fetzer Vineyards.
There's no thrill like discovery. The Discovery Channel. Explore your world.
At the Railroad Transportation Technology Center, they're developing ways to increase the level of braking power even further for trains of the future. Here they are testing the difference between old-style air brakes and newer electric braking. Electric braking sets the brakes on each car of the train within seconds. Older air braking resulted in a delay that would take a train several miles to stop. All of the locomotive's integrated systems are controlled and monitored in the cab, the nerve center of the train. The gauges and handles that yesterday's engineers worked have been replaced by computers and digital displays. You don't drive super trains, you pilot them.
The diesel today is a high-tech machine. Even back in the beginning, when General Motors was pumping out 6, 7, 8, 9 units a day, they were saying that pulling diesels off an assembly line was like pulling submarines off an assembly line. They were that complicated. But that was before the day of the computer, the day of a lot more automatic controls. Back then, fans were driven by belts. Today, they're driven by individual motors. It's an altogether different machine inside, even though it looks somewhat the same as it does on the outside.
Even with all the computer and high-tech integration of today's locomotives, working on these monsters is still a back-breaking job. At the Santa Fe shops in Barstow, California, people work around the clock to repair locomotives as they come in for service and inspection. Each of the locomotives has a scheduled inspection every 92 days. And once on the rack for service, the locomotive is fueled, sanded, all fluids checked, and then cleaned. There's even a locomotive wash, which is very similar to your neighborhood car wash. It is turned around and ready for the road in about 2 hours. If more extensive work is needed, the locomotive is pulled into the garage. Here, changing a 3-ton wheel set can be accomplished in about as much time as it takes to tune up an automobile.
Going up.
Safety is the most critical of all considerations when working around locomotives, because when injuries do occur, they are usually serious. In railroad design labs and manufacturing plants, a new breed of super trains is being born. Scientists and engineers are experimenting with advances in technology such as computer-aided design. This is being used to create models of locomotives prior to construction. These prototypes can be tested and modified without ever lifting a wrench. Braking and propulsion systems, traction controls, rail geometry. These are driving locomotive technology to new limits.
High-speed rail can accelerate much faster than we're planning to accelerate at, but it's a comfort factor for the people. We're not trying to build a roller coaster. We're trying to build a system which is comfortable. People could be strapped into their seats and operate at much higher speeds, but nobody could be able to hold onto a cup of coffee or anything in the service. So the service is designed to provide people with a sensation of moving, but without a sensation of being thrown